Hey everybody, it's Dr. Schulman. I thought I'd just keep this going because I was really trying to put together some good stuff for you to see, like different ways for modeling, because 6F also has modeling stuff in it where you really just help your students visualize things in 2 and 3 dimensions. So I thought I'd give you some really useful tools to just help you get there. So that's pretty much my goal right now is I'm going to show you stuff that I've used in a bunch of classes. There's other ones that are good. There's Patterson materials. There's other pieces. And if you guys like Patterson, feel free to reach out to me. I've got all of the Patterson stuff together. So you can just ask me for it, and I'm more than happy to share. So what is 6F? Is strategies to model real world problems involving 2 and 3 dimensional figures. So that's what we're doing. I'm going to share my screen and I'm going to just start by just giving you some really good idea. Well, hopefully good ideas, but stuff that I've used. So here we go. I was putting these together and I was like, I might as well just do this one for you right now. Because they're all in my head. So we're still in this first part of geometry, but that's okay. I think there's the quiz that I'll do. I'll make it when I'm done. There's going to be composite shapes. There's going to be a bunch of stuff in there. So, but notice, and if you want more of the answers, I just give you answers to one of the sheets. So this, I think, is one of the best ones. So this one's called this lathe activity. So you can actually go and actually use the lathe, um, and actually cut into it to see the shape, which is cool. So basically, these I think are really tough. I should probably open 2 of them. All right. So basically, if I have two side by side, I feel like it's the best way for me to explain it. Oops. All right. So here's two side by side. Okay. So basically, for this one, we're spinning a two-dimensional shape around something. We want to know what it turns into. So we'll start with the easiest one, which is number 4. Then we have all of these choices. So it's just a tiny little thing getting spun around with a big open hole. Which shape is that? Looks a little big. This one's really thin. I don't think it's U. Yeah, this one's U. 22 is probably U. But I want to start with 4. 4 is probably going to be O. 4 looks like O. And then you have to see which one is these pieces are going to be. This one's thin with a jutting out piece. This one has the middle juts out, so it can't be 8, but it's got to be the inverse of 8. I mean, the invert 8 is the inverse of whatever n is. Is there an opposite n somewhere? Unless I'm not seeing it. Oh, here it is. Here's the opposite. There it is. So this is D. 8's got to be D. So, because there's a space here, that's why there's a hole. I would really push you guys to try these. They're really fun. If you want to cheat and look at the answers, you can. And then they get even more challenging when you go the other way. So if this is what it looks like, what does the shape have to be? If this is what this one looks like, what's the shape? It looks like this flying saucer, what's the shape? So these are really cool to have your students push and try to solve. Want to see the answers real fast? Here's the answers. Make sure I got that tiny one right. Is 4O. 4 I said was, well, not Q. Where's O? Oh, it's over here. Yeah, I got that one right. Cool. So try your best. They're really tough. Enjoy them. Okay. I think they'll be really useful for you. Okay. So what's another thing? Another really good way to see modeling. So here's a two-dimensional model. Well, this one's kind of the same. I'll do this one first. So this is the same idea, but now we're kind of thinking about it vertically. So if I take a triangle and I spin it and I spin it and I spin it around, it's going to turn into a cone. If I spin this semicircle, it's going to turn into a sphere. And your whole thing is to figure out this is going to be a cylinder because it's a rectangle spinning around. Don't be afraid to just pick up a piece of paper and spin it around real fast and have them try to visualize what it is. This is what would the cross section be? So we would see what that turns into. So a hemisphere on a cylinder. If we were to cut this thing, what is the cross section? Then you get to look at some vases and try to think about it, what it would be. So I really think these are good. And if we have this, what is the solid going to look like? So I think these are all really good ways to get your students thinking, get your students really trying to understand what happens when something's spun around. Okay, so we might as well step it up. I don't know why everybody messes up these dog leash problems, but it is what it is. Here, let me download this so I can kind of show you how this works. I'll do maybe two of them. So we did two that were 3 dimension, and I wanted to have two that were 2 dimensions for you to see. So I can draw on it. Students like it because there's like animals. They can try and practice with a compass. So here we go. Starting with our good friend Scruffy. So Scruffy the dog is on a post with 6 foot leash. What is the total area? Well, if I draw it, I'm just going to draw a big old circle. The one area, that's just pi r squared. 6 squared is 36 pi's. And then you can multiply if you want. We'll leave it in terms of pi for now. Feet squared. But now we got Buzz. Buzz is trying the same thing, but oh no, boom, boom, boom. So it's 12 feet. He gets stuck. So this is where Buzz can travel. Is it a whole circle? No, it's going to be 3/4 times pi r squared because it's not the full circle. They get harder. So here's our buddy Billy, the goat. So this is 15. He's not going to get all the way around here. So this is a quarter circle at a radius of 8. So I usually do it this way. I usually do 1/4. I usually break it into parts, but you can show it any way you want. 1/4 pi r squared with this is going to be 8. So one of them is going to be 1/4 pi 8 squared. Now I'm going to go around. Got another quarter. So we're at a half. Now we're at 3/4 like we were before. So here's how it starts, just like the last one. But this is 8 and this is 5, right? So I have a little bit of extra give. So if this one's 8 and this one's 5, the last quarter is going to be 3 because 8 minus 5 is 3. And then you just multiply, work them out. I'm leaving you the last one, the porcupine one, right? Yeah. So this one I'll make a big extra credit. So if you can solve this, I guess without cheating or looking at the answers, I don't know how many extra credit points you want, but I'll give you like 15, 10. 10 sounds fair. So we'll do 10 points extra credit on geometry test. Actually, no, it's a hard question. We're going 15. We'll go 15 points. If you can get this one right, I'll give you 15 points extra on your geometry test. Cool. It's tough. It's tough. Poor Pauline. All right. So here's the other one that I gave. So this is going to be on slide 18 for this. So this is the easiest one. So here's the future authentic problem. So you stop by Home Depot. Oh, and I'm going to need something to draw to be able to solve this one because it's tough. All right, so we stop by. Come on, there we go. And we should be in. All right, we did E. We're on F. So modeling for 2 and 3 dimensions. So we just did 2 that were 3D, and here's the second one for this one. So we stopped by Home Depot to buy. This is a really common problem. This dog one's been all over the place. How do I zoom out? How do I get rid of this on the side? Nice. Cool. I did it. Technology is going to be my friend. So we stopped by Home Depot to buy fencing because your pit bull, Princess, is now up to 51 pounds. Oh, Princess. And keeps barking. Your plan is to train her to become an outside dog. You purchased 64 meters of fencing. Yeah, 64 meters of fencing to build a rectangular pen. Okay, cool. What are some of the different pens you can make? So if I have 64, do you want it long? Do you want it fat? Do you want to go 20, 20, and so that's 40, right? Okay, so these would be 20 if we're going that way. And so we're left with 24, 12 by 12, right? So that's one of them. And you could just play around. You can go 10, 10. So that's 20, and then we could do 22, 22, you know? That way we can use 64 of it, which would allow for the most space to run. How can we give this dog the most space? The most space. So you can really think about it. What would be the most space? Are we gonna, we said rectangular, so which one is the most space rectangular? I don't know. I think it's probably gonna be a square, right? It's 16, 16, 16, and 16. I think that's the most space. I'm pretty sure a square maximizes the area. Yeah. But what if what would be the least play area? Okay, so is it going to be 1 by 1 and really long? So 1, 1. So that's 2. And then it's going to be 32, 32, right? I think that's 32 and 32 is 64. So 31 and 31 is 62. So yeah, I think this is the least amount, unless you want to go half, um, fence it up around that way. So, and then you can keep going. So if you want to do one without a rectangle, well, you get more area. So really think about it. You can try the rest of these for fun, but I just really wanted to show you modeling ideas for 2 and 3 dimensions that could be really useful for students. All right, so let's jump into the problems. I hope these are useful for you guys and girls and theys. Sorry, I'm trying to get better at stuff like that. But I just gave you the answers to one. But if you want the answers to any of these besides the extra credit, just ask. I'm more than happy to share as many resources as I can to help you be effective. All right, so we're doing F. F is it's going to be a short one. There's not much. It's about just kind of creating them. So let's get after it. So here's F. Yeah, there's not a lot here, and most of them we've done already. But I still practice is good practice, right? Yeah, that's the only skills we have. So let's go with it. So we got the water tank, which we've done a bunch. So that is how many cubes? I believe that is 6 cubes. And then we have 6 times 4, so I believe that's 24 cubes. And then 24 times 3 is 72. We should be 1 for 1. All right. So what is the volume of a rectangular prism with a height of 3, a width of 7, and a length of 6? Give your students a prism. Give them something. It's not modeling if it's just it in words, but this is 3 times 7 times 6. 3 times 7 is 21. 21 times 6 is 126. Right, so let's do a prism one. So here's a hexagonal prism, and it gives you the base. It's always the base area times the height. So if it gives you the base area of 23 and a height of 5, this is any shape. Volume of any shape is just base area times height. So they already broke it into triangles for us. So it's just 23 times 5. 115. And notice it's cubic because it's filling the space. Cylinder has a base diameter of 12 and a height of 18. So for cylinders, the volume, I always find volume easier to visualize than surface area because I don't paint a lot. So if its diameter is 12, that means its radius is 6. So 36 times 18 times pi. I was just checking the units, make sure they match so I didn't get messed up like that one problem. Times pi. 2035.8. All right, we got a rectangle prism 2 by 7 by 6. We literally just did this. I'm going to take this out because it's literally just the same thing that we just did, just together. You don't need to do an extra one of this. Okay, so let's do a cone. Now there's a really good cone. I have it somewhere, but a cone to cylinder spell GIF might be good. There's a bunch of these. They're all kind of the same, but you just get to see. So how many cones fit in? Now we want to see how many fit in to the cylinder. Here we go. I knew they'd give us one eventually. That makes sense. Oh, no, that's just a cylinder. Here we go. 5th time's a charm. So 1/3. Ta-da. I always show my students this way that 3 of them are going to go in. So you got one here, got one here, and one here. So instead of pi r squared times height, it's 1/3 pi r squared times height. Cone has a height of 14.3 and a base radius of 5.3. So all we have to do is take 14.3 times 5.3 squared times pi, and then we divide it by 3. So we can do 5.3 squared times pi times 14.3. We just divide this answer by 3. And to the nearest 10th is 420.6. There's your code. Let's do a level 2. That's it. Okay. Level 2 is real easy. I don't know why, so let's do it. So it's 3 squared times pi times 6, and then we just divide it by 3. So we could have just times it by 2. Oh, it's in terms of pi. Okay, so sorry. So we have 3 squared divided by 3. Literally brings us right back to 3, and we just times it by 6. It's 18 pi's. Because the 3 and one of the 3's cancel. All right. So now we have a pyramid with a square base, which means it's made up of little triangles. So instead of, it's still base area times height, but because it's a pyramid, I'm pretty sure we do 1/3 base area times height. Because it's like the same thing with the cone. So the base here is 15.4, the height is 15.6, then we just divide it by 3. 15.4 times 15.6 divided by 3. I believe it's to the nearest 10th, 80.1. Let's see if that's the right formula. Nice. Volume equals 1/3 base area times height. And those are your steps. All right. Maybe they'll give us a harder one. Who knows? Nope. Oh, they give us, oh, so we have to go backwards. So 1/3 base times height. So we have the volume is 1078 equals 1/3. And then we have the height, which is 21. And then we just know that the base area is a rectangle, which is 14 times x. I'm going to cross those out, make it 7. And I'm going to divide it by 7. $154. All I have to do is divide it by 14, and then we get the other part of that rectangular base. I know it looks like a square, but it's not. It's a little bit shorter on the sides. 11. Ta-da! Maybe there's a little different, but that's okay. They multiply these first before dividing. All right, so now we can do a sphere. So I'm not going to mess this up. I remember what a hemisphere is. It's literally like a sphere, but we're only doing half of it. So volume, so this is 4/3 pi r cubed, but we want it in half, so I divide the whole thing by 2 at the end. Well, I'm a hemisphere with a diameter of 4.2. We want the radius, so that's going to be 2.1. Okay, let's make it happen. So it's 2.1 cubed, so 2.1 times 2.1 times 2.1 times pi. All right, so that's everything before the 4/3 divided by 2. So we're going to multiply by 4, then divide by 3, and then divide by 2. You could divide by 6, but this is just visually what looks right to me. To the nearest tenth is 19.4. Perfect. Half of it, 19.4. All right, let's step it up to level 2. What is the diameter of a sphere? Okay, so it's the same thing, just backwards. Volume equals 4/3 pi r cubed. We have the volume 26393 equals 4/3 pi r cubed. Let's get rid of the 4/3 first. So instead of dividing by 4/3, we're just going to multiply it by its reciprocal. What are you doing over there? So we're going to multiply this by 3 and divide it by 4. That's our first step. Or you can just multiply it by 0.75 if you want. If you hate fractions, literally just do 3 divided by 4. Work with 0.75 instead. Multiply that by 26393. And now we have no more 4/3 to deal with. The next step is to take this 19794.75 and we just have pi r cubed. Now we divide it by pi. So divided by pi, some crazy number, 6,300. So the opposite of a square is square root. The opposite of a cube is literally a cube root. So we have to figure out what number times itself once, twice, 3 times gives us this. They don't have cube root function on here. We have square root. All right. That's annoying. I'm just going to use Desmos. All right, so we want the get out of here. All right, we want the oh, sorry, functions. I'm just going to type cubed root. It's not going to be that. So I went by too fast. There's calculus, there's geometry. That's adding sounds. Oh, here it is, cube root. So we want the cube root of 6300.864. 18.5. Is it one decimal? Yeah, 18.5. Wild stuff. What? Oh, because they wanted the diameter, and I gave them the radius. I'm over it. All right, let's do a mixed volume one. What is the volume of a cylinder and the base of this? Same thing. Pi r squared times height. So we have the diameter, which is 12.4. So this is 6.2 squared times 8.2 times pi. Pi times 6.2 times 8.2 to the nearest tenth, 159.7. I forgot to square it. I forgot to square it. Well, I've done enough of those. You're okay with it, I'm sure. And we did the compare the water tank one. Yeah, we're not going to do another one of those. I'm actually going to knock both these out. Let's get rid of the mixed. And let's get rid of this one. Cool. All right, let's do some harder ones, right? So we're up to scaled solids and volumes. We've got some revolutions, right? Yeah, let's step it up. This solid is dilated by a factor of 4. So every one of these has to go up by 4, or we can do 4 cubed, which is 64 times the final answer. This is the other way. This way I didn't do it before. 5 times 3 times 9 times 64. 8640. What a cool way to do it. I've always just did each side by itself. 16. Oh, because it's surface area. Surface area. Not volumes, not side times side times side. So it's only by a factor of 2. All right, let's do a new one. We got a rectangular pyramid after dilating by 1/5. The surface area of the pyramid is 100. Find the surface area after it. So it's 1/5, but it's squared. So it's 1/5. 1 divided by 5. We have to square this. We have to times it by 100. We should get 4. Nice. Nice. 100 times 1/5 squared. 100 times 1 over 25. It is 4. One more just for fun. What is the volume? Okay, so factor of 4. So it's to the 3rd power. Because we're talking 3 dimensions instead of 2. So that's why when it's surface area, it's the answers are all squared. That's why you would take the scale factor and square it. However, if it's volume, it's cubed. So you have to take the scale and cube it. So this is going to be 4 times 4 times 4. So that's 64. We want it in terms of pi. So it's 6. So this is just pi r squared. So it's 16 volume equals pi r squared h. So it's going to be pi times 16 times 9. So it's 16 times 9 times 64. Nine two one six pi. 9216. Nice. What a great problem. These problems are really good. I would normally do it a different way, but I like this. All right, so here we go. Revolution, not calculus. Find the volume of the solid generated by the semicircle spun around its diameter. So this makes a what? You have to know that if we spin this around, we're going to have a sphere. So it's 4/3 pi r cubed. So it's 4/3 times pi times 8 cubed. 4 divided by 3 times pi times 8 times 8 times 8. 2144.7. These are tough ones because you have to visualize it spinning. Nice. Whoa. Whoa. All right, let's do a second level. Two rectangles are joined to form the figure below. Find the volume generated when the figure is rotated around AB. So this is tough. To me, this is double cylinder. It's a rectangle spun around. I'll do this one. That's what I'm visualizing. This thing spinning around and then the little bit spinning around. And I'm going to add them together. So I'm going to do this piece plus this piece. We could have done another way we could think about it as the whole thing spun around. Like if the box was full, like here's the box, right? There's your, I'll draw it better, sorry. So we could imagine the whole thing. We could subtract the little cylinder. But to me, when I look at this, it's this piece spinning, and then it's this little piece spinning. So it's two cylinders. So volume equals pi r squared h plus volume equals pi r squared h. This, if it's spun around, that's the radius. So the radius is 4, the height is 5. So the little one is 5, 4 squared pi's. I'm going to add them together. So here's 16 times 5, 80 pi's. Cool. Get out of here. All right, this is 8. This whole thing is 11, but that's 5. So our other height is 6. This is 8, but our height here is 6. So this other one is 6, 8 squared. So it's 64 times 6 pi's. 64 times 6, 384 plus 80. And we finally have them together, so the whole thing's 464, then we just multiply it by pi. Probably the best problem in this entire course so far. To the nearest tenth, 1457.7. Whoa! Double cylinders. Nice, nice. It's exactly like that worksheet I showed you. Beautiful. All right, let's go oblique. We did this already. Do I have another one? We'll take out the one with the Pythagorean theorem because we did that already. So this is the base area is 3 times 4, 1/2. So that's 6 times 4. So this is base area times height. But because it's a triangle, it's 1/2 base times height times like the big old height. So 3 times 4 is 12. 12 cut in half is 6 times the actual height is 4. It should be 24 units. And I'll get rid of the Pythagorean one. Boom, boom, boom. So you don't got to do that again. And I think I have to take out this one because it's trig. Yeah. Yeah, you don't have to do trig. I want to show it to you, but if you want to know about sine, cosine, tangent, just let me know. All right, we get to do the matching. Whoa, I'm so bad at these. All right, A, B, wait, what are we doing? Match the solid below to the two-dimensional shaded region. Ooh, So it's a 2 and it's a 3. It's a, oh, it's A. I like A. Nice. And since I took some of these out, you actually have to do 3 of these. Why? Because this is like the most important one. I'll do another one too, even though I'm terrible at it. We need the space, but the space should only be one space. One space. That looks good. I'm going C. Nice. Wild. All right, let's do Cavallari's principle. In the solid below, all of the cross sections are parallel to the base are rectangles. The measurement, this measures 12 by 4. The perpendicular height is 5 units. Use the drop downs. The volume can be determined because all cross sections are parallel to the base of the same area. Find the volume. I believe it's 12 times 4 times 5. I think as long as they're parallel, you're good. As long as these are all parallel, you can solve it just by doing length times width times height. I'm pretty sure that's this guy's principle, but why not look up this human and see what he or she or they look like? There he is. He's Italian, right? I thought it was Italian. He was an Italian mathematician and a Jesuit. He did optics and motion. That's cool. And his principle. That's so. So let's see if I actually did it right. You know? Uh, So the volume cannot be determined because not all cross sections are parallel to the base have the same area. Oh, so they all have to have the same area as they go. That makes so much sense. So if they have the same area as they go, I want to see this again. What a cool. See, they're all the same areas so they can get shoved in together. Nice. It's been a while. Cavallari. Let's do another one. These are not all the same. They are not all the same. So the volume cannot be determined. Not all cross sections have the same area. Thanks. Look at me go. I just learned the Cavallari principle. Well, I've relearned it. These are all the same. So yes, they can. All cross sections are the same. It's 8 by 8 by 7. 8 times 8 times 7. And thank you, Cavallari, 448. They're all the same. All right, the last two, the cross sections of solids. Oh, we should do 2 of these. You should do 3 of them. All right, rectangular pyramid is pictured below. These are all going to be when the figure is cut containing the altitudes. That's up and downs. We're talking triangles there. That's got to be a triangle. Nice. Solids cut in plane parallel to its base, forming its cross section of a triangle. D for sure. All right, and here's the last one. Can of soda can be modeled as a right cylinder. Clear measures a radius of 2.5 and 230. Find the height in are they all centimeters? Yes, they are. Soda can. Just cylinder. Pi r squared times height. You have the volume is 230. Our radius is 2.5. I'm assuming we need the height. Yep. So we just divide this by pi 2.5 squared divided by pi 2.5 squared. And guess what? We've got everything. So hopefully this one was useful. I hope that the other pieces that I put in, all the additions, were going to be good for you. Divided by pi divided by 2.5 squared. Boom. 11.7. So there's only one more left. It's G. I'll do that one next. And then there's these other pieces of geometry. I put a bunch in here for manipulating stuff. I've got scales, I got congruence, I got reflections, I got all this stuff, composition of transformations. There's a lot of extra stuff in here, so I might delete some of them, but just spare warning. If some of the stuff doesn't make sense, just reach out, and I hope you enjoy your day.